Welcome to the Explainer. Today, we're going to pull back the curtain on a technology that literally shapes the world around us. Yeah, I'm talking about the phone in your hand, the car you drive, and so much more. Have you ever really thought about how a solid chunk of metal becomes something super complex, like a part for your car or your phone? I mean, look at this. It looks like just a shower of sparks and raw power, right? But what you're actually seeing is an act of insane precision. Well, the secret behind it feels like magic, but it's really this incredible technology called computer numerical control, or CNC for short. All it is really is telling a machine exactly what to do using computer code. And that simple idea, it completely revolutionized how we make things, letting us turn digital plans into real-world objects with accuracy that was honestly unimaginable before.
All right, so let's get into it. To really get a grip on CNC, we first need to understand the two basic ways we make, well, pretty much anything these days. It all boils down to a simple choice. Are you adding material or are you taking it away?
Now, you've probably heard of the first one, additive manufacturing. Think 3D printing, right? You're building something up from scratch, layer by tiny layer. CNC, though, is the total opposite. It's the master of what we call subtractive manufacturing. You start with a solid block of something and you just carve away everything that isn't the final part. And this picture just shows it perfectly, doesn't it? On the one hand, you have building up, but on the other, you're carving away. You start with that solid block and just remove all the extra material. It's kind of like a sculptor who sees a statue inside a block of marble and just has to chip away the rest. So how does this actually happen? How do you go from a design on a computer screen to a real, solid object that you can actually hold in your hand? Well, it's not just one magic button. It's a really cool and super precise digital workflow. It's basically a three-step journey, and each step is absolutely crucial. It's what connects the designer's imagination to the raw power of the machine. Okay, step one. It all starts with the design. A designer uses software called CAD, that's computer-aided design, to create a digital blueprint of the part. And I mean every detail, every curve, every hole, every single surface is mapped out with total mathematical perfection right here on the screen. Then comes step two. That gorgeous 3D design gets translated into a special set of instructions called G-code. Think of G-code as the language the machine speaks. It's a whole bunch of coordinates and commands. Each line tells the machine exactly where to go, how fast to get there, and how deep it needs to cut. It's literally the script for the machine's big performance. And finally, step three, execution. The CNC machine takes over, reads that G-code line by line, and just does it. With incredible accuracy, it automatically carves the part out of the raw material. This is the moment the digital design finally becomes a physical reality. Now, the real genius here is the machine's control unit. It's basically the brain of the whole operation, and it's a smart one. See, it doesn't just blindly send out instructions. It works in what's called a closed loop. So you have these little feedback devices that are constantly telling the controller, hey, this is where the tool actually is right now. And the controller uses that info to make tiny adjustments in real time. It's this constant back and forth conversation that makes the whole thing so unbelievably accurate. And you know, when we say CNC machine, it's not just one thing. It's actually a whole family of different computer-controlled tools. And each one is a specialist at its own particular job. I mean, you've got mills for carving complex shapes in metal, lathes that spin material around to make perfect cylinders, you've got routers for things like wood and plastic, and then you have the really high-powered stuff like laser and plasma cutters that can just slice through steel like butter. Seriously, whatever material or task you can dream up, there's probably a CNC machine built for it. Okay, so what's the big deal? Why is this technology so fundamental? Why does it matter so much to how we make things today? What's the secret sauce? Well, it really comes down to this idea of perfect translation. CNC lets us start with a totally flawless digital idea, a perfect blueprint that's just, data on a computer, and turn it into an equally perfect physical thing. And not just once, but over and over and over again. Think about it. The machine doesn't get tired. It doesn't have a bad day. It just follows the plan perfectly every single time. And that leads to four huge game-changing advantages. First up, precision. We're talking repeatable accuracy down to a tiny fraction of a human hair. That's what makes things like medical implants in jet engine parts possible. Second, automation. These machines can run 24/7 with basically zero manual help, giving you perfect consistency. Third is flexibility. You can create these incredibly complex shapes that no human hand could ever hope to make. And finally, efficiency. This is what drives the speed and the sheer scale of modern manufacturing that we all depend on. So next time you pick up your phone and feel that perfectly smooth metal case, or think about the complex parts inside a jet engine, remember CNC. It's the hidden force behind so much of the quality and precision we just take for granted every single day. It's like an invisible artist, shaping our world, one line of code at a time.